anyway, so welcome everybody. Thank you for attending this webinar series. I'll say we're talking about access network modernization, and I know that's a mouthful. If you're familiar with Cisco parlance, we'll be talking about the access layer of the network and all the things that are going on in that space. So, but before I begin, I saw the participants list. I think I know most of you, but if not, let me introduce myself. I'm Jeremy Ryder. I'm an enterprise architect here with NSI. Have been with NSI for, I think this is my 11th year. Enterprise architect just means design engineer. I work on the design side of the house prior to a purchase, just to help you guys figure out exactly what technologies you need, maybe some technologies that may help you in different scenarios. And so many of you I've worked with, and thanks for coming back. Prior to this, I was our team lead for the routing and switching install side of the house. And so did a number of installations from that perspective. And before that, earned my stripes doing the grunt work of moving things around. So like I said, I think I'm in my 11th year here, still enjoying it, and I expect to be doing networking for quite a while going forward. So that's a bit about me. What are we discussing? So as I said, the series is access modernization. In particular, we want to focus on the changes that are going on in our network access space. So for those that are not familiar, the access layer, especially if you see any design guides, again, in Cisco kind of parlance there, is the point of the network that we're plugging all of our devices into. And I'm going to expand that to mean not just plugging into physically, but maybe logically with wireless connections as well. So this is where you're plugging your phones and your printers into, and all the switches that make that up, and then obviously all the access points that we're connecting to from a wireless perspective. So we'll dig into that today and talk a little bit about faster access, some of the new requirements that are going on that are driving that faster access, some of the new technologies that have been implemented to facilitate all these new requirements, and then some of the new products that Cisco has that can enable that faster access. As always, we've got the chat, and I actually have that hidden right now. I should find a way to pull that up, but I'll focus on the presentation here. Ben, you chime in if you see any Q&A come up. At the end, though, I'll obviously hang around so we can go through any questions. And then lastly, so today's focus is, like I said, faster access, but come back, because in 2 weeks and then roughly 4 weeks from now, we'll have 2 different webinars, respectively. Better access, which is going to dig into monitoring and managing, because as our speeds increase and our bandwidth increases and our devices increase, my perspective on the customers that I work with is the IT teams are not increasing. And so there's more for all of us to do. And we do have some tools that can help with that, though. So that'll be the monitoring and managing piece. And then finally, anybody that's been doing this for more than the past month will tell you that security has to be top of mind, and that pervades all of our all aspects of networking. So at NSI, we certainly have a security architecture team, but even on the enterprise networking and our server teams and our collaboration teams, you've got to have security as top of mind. So we'll have one more webinar there December 14th. If you didn't see the invite already, you can go to nsi1.com/events and register for either of those webinars. All right, but like I said, today we'll be focused on faster access. So let's jump into those new requirements. And many of you have probably felt this already, but I thought it was worthwhile calling out at the beginning just to get us on the same page. So no surprise here from left to right. We just see in today's networking world, there's a lot more apps that we have to provide service for, especially some bandwidth intensive apps, such as 8K video and virtual and augmented reality. Some of that you may be seeing already, you may not be seeing, but especially as we plan our roadmap for our networks over the next 10 years. What things do I see on the horizon that I need to support, and I need to build an architecture that's going to perform against. These applications are driving more and more content that needs to go over networks. You can try and think back 10 years from where we are today and what the network requirements were and how much that's grown. And so that's something that's especially being looked at as we look at rolling out new network access, as well as protocols. So this one surprised me a couple years ago, but it's definitely the trend and the direction that we're going in. So you can see here 60% of IoT devices connect via non-Wi-Fi protocols. So sometimes we don't think of it intuitively, but there are other wireless protocols outside of Wi-Fi, and that's what is getting at with this point. In that you can see, smart bulbs or different sensors, or indicators, smart buttons, those kind of things are becoming more commonplace, both in the enterprise space and the home space. Many of us probably have some kind of smart home devices of some kind. Well, those communicate on Bluetooth Low Energy, commonly BLE. Zigbee was a popular one for a while and is still around. And there's a new kid on the block, Thread, that promises some enhancements over both of those. But in the enterprise space, we've got all these access points dispersed, physically through our buildings. Some of these wireless protocols, it would be useful if we could give them access to the network via those access points we already have deployed. And so it makes a lot of sense if you're an IoT device manufacturer to leverage those things. That's becoming a requirement in our access layer as we push some of these out. Mobility as well, and this is just an expectation, right? We've got users, they've got expectations, and sometimes we have to push back on those expectations, but we also have to service those expectations a lot of times. So what users are going to be accustomed to in one space, be it at their house, be it cellularly, we have the advent of mobility and just speeds increasing. It says here will triple by 2023, and what that's getting after is the adoption of 5G on the cellular side, which you may be required to provide some kind of backbone for. But certainly for us, Wi-Fi 6 and Wi-Fi 6E, and how that will affect mobility. Cloud we'll come back to. I've got another slide for that now. We'll talk about that in a minute. But notice that 92% of enterprises have adopted a multi-cloud strategy. You can even think over the next few moments here if that applies to you. I already talked about more devices, IoT, and then certainly security. I don't think anyone would argue there's an evolving landscape that at the access layer we can provide some support on. So like I said, that'll come in a couple webinars from now on December 14th. But that is certainly part of the modernization of the access layer and what we're seeing. Multi-cloud is also another push, and this comes back to our user expectations in this case. So it said it on the previous slide, 92% of organizations are multi-cloud. And again, something I heard initially, and I was like, well, I don't think I'm multi-cloud. I don't think we're leveraging multi-cloud. And then I had to realize I was mistaken, because I was thinking about this box here, which is hard to see, but that says IaaS, infrastructure as a service. So many of us initially were introduced to the cloud thinking of what are my on-prem applications that I'm going to move out somewhere else, AWS, Azure, GCP, that I'm going to, instead of hosting them in my own servers locally, I'll host them out there. And that was certainly at least my introduction to cloud. But that cloud word has gotten used and abused in other ways. So now your own data center on-prem might be referred to as your private cloud, and you're hosting applications there. Well, we have necessary access requirements that go in accessing those services. If they're located either in these public cloud providers in AWS, Azure, Google Cloud, or be it on-prem. And then there's been a proliferation of software as a service and cloud services. I would guess 92% of organizations rely on Office 365 at this point. There's some kind of file saving service as well, be it Dropbox. Many people are G Suite Google customers, and so we're taking advantage of a number of these cloud services. And so again, we have to service users' expectations and being able to access those services, be them business relevant or not, and then trying to figure out how to do that in a secure way. So a lot of these demands are changing. Now, when we think about faster access, Wi-Fi is certainly meeting this demand. And hopefully some of our messaging and the industry's messaging as a whole has gotten through. In the chat, who can tell me the biggest change between Wi-Fi 6 and 6E? So you should have in the chat the ability to send that message out, and if I can get to it. Let's see, where'd my WebEx go? No, I lost it. Ben, can you read that out if you see that?
Yeah, we haven't gotten any answers yet.
Oh, they're shy.
Shy.
That's
Oh,
the chat.
Ethan, here we go. There's the chat. Ethan Purdy says 6 gigahertz band.
Nailed it. Ah, see, that makes me so happy. We're getting the message out. Well done, Ethan. Thank you for your contribution today.
Thank you.
That's perfectly correct. And I wanted to highlight that. I think there's some mystery as far as the difference between Wi-Fi 6 and 6E. 6E just came out, 2019 is listed here. 6E in 2021. They are effectively the same protocol. There's a couple minute differences between the two, but they are effectively the same protocol. The big news here is that the new 6 gigahertz band, and yeah, the answer was on the screen there, is available to us. And so part of the, I try and simplify this in just saying that a big advantage between Wi-Fi 5 and Wi-Fi 6 is this methodology of almost using like a talking stick in a room. So Wi-Fi 5 is all about shouting out the information that you want to get out there into the room, and everybody shouts at the same time. And so we have to do collision detection and set a timer. How long should I wait until I try shouting out this information again? And so as more and more devices have shifted to wireless, that has become an issue because now we just have too much chaos in the airspace that we're leveraging. And so 6E tries to coordinate and schedule all of those communications. We have a talking stick. You can only talk when it's your turn. And that's been phenomenal. But adoption is hindered because I still got a number of noisy Wi-Fi 5 clients in the environment. And that'll change over time. But right now, adoption is hindered because of that. Additionally, we have some spectrum issues, and this is what the next slide talks to. In that, I only have so many channels that are available to me. So again, as more and more devices jump on the network, I need more and more airspace to communicate on. And so going back to 2.4, you can see we had 3 non-overlapping channels. And we would divvy up the environment to try and make sure that we didn't have overlapping channels in different spaces. 5 gigahertz certainly expanded that, but then we got this weird gap in the middle. For those that are familiar, that was known as the DFS, dynamic frequency selection, because we were, overlaying was, I think, some military radar systems or something like that. So you always had to be careful not to leverage that. Well, forget all that. Now we have the 6 gigahertz space, which for 6E capable clients now gets all the benefits of Wi-Fi 6, protocol standards and that ordered communication. And complete, pristine, untouched. It's like a brand new road, is how I like to think of it, where we can communicate on. And so the promise, and I'll go back to this slide, you can see over the years how our data rates have changed. Theoretically, out of 6 and 6E, getting that 9.6 gigs of traffic. Now, theoretical, completely optimum space. You have to be within a certain amount of distance to the access point. You're not going to see this in practical application. But getting a gig and greater is certainly within reach now because of that new ordered communication and because of that new 6 gigahertz band that gives us kind of a brand new road to work from. So this is a big deal as we move into, we'll call it the modern access layer from a wireless perspective. And we'll come back to how we can utilize this with some new products in a little bit. Let's take a moment, though, to look at switching, which also has some changes and new technologies that need to be supported. So I just talked about Wi-Fi 6E and that new pristine environment and our throughput rates. Theoretically, we're pushing almost 10 gig, but now we're looking at 1 gig. So it's a decent rule of thumb to think about in my mind. So now we have a problem, though. So much like years ago, we had switches that, I got 48 1 gig ports that I'm connecting on, going down to phones and desktops and laptops and all kinds of things. I would need to look for a backbone that had more throughput. Because if I got 48 1 gigs coming in, I got 1 gig going out. Well, there's a high likelihood I'm going to have some kind of congestion on this link. And so we shifted to 10 gig and maybe beyond backbones to support that kind of traffic. Well, now we have the same thing going on the access point side, where I'm going to have 30, 40, 50 devices connected to this access point at 6 or 6E speeds, and I've only got a 1 gig connection going back to the switch. Well, now I've got a problem. So obviously, Cisco's been looking forward to this and worked with the IEEE and then formed this N-base-T alliance. And now we have MGig capability or multi-gigabit capable ports. So with that standard, you're able to leverage 2.5 gig speeds or 5 gig speeds or 10 gig speeds, all on existing Cat5e or greater cabling. So we don't have to put new cabling in. There's a distance limitation with 10 gig on the Cat5e cabling, but we can dig into that certainly if that's your situation. So the point here is on these switches, I now have to support those MGig speeds. And if you've had a conversation with me over the past, I'm not sure, 6 months, a year, we probably dug into this a little bit, especially as it pertains to new Wi-Fi 6 and 6E access points, because these really should be mapped back to some kind of switch that supports MGig. Now, it's not to say a switch that only has 1 gig ports, if you plug one of these APs in, won't work. It certainly will work. But obviously, now we're entertaining a bottleneck of that 1 gig speed. The other thing we have going on is smart buildings. And so, like we talked about with IoT, there's a lot of sensors, a lot of lights, cameras, different displays that would like to be connected to the network. They want to become smart and have some kind of data go back and forth, reporting on their utilization or pushing some kind of configuration. But we can simplify that also by not only making them smart, but allowing the power that's available via PoE in our switches to power those things. That does mean, however, there's an increase in the amount of power that we need to provide from the switches. And so there are new standards. You can see here 90 watts. That is referred to UPoE plus. There's a 60 watt standard referred to as UPoE. And for a number of years, we've been relying on a 30 watt standard referred to as PoE plus. So a couple things, I need to be able to provide more power for my switches on a per port basis. So you'll see switches rated for different per port PoE capabilities, be it that PoE plus 30 watts. That's very standard at this point. But UPoE ups that capability to 60 watts. And then UPoE plus ups that capability for each individual port to supply up to 90 watts of power, which you're getting into some larger displays, maybe some cameras with heaters at that point that require that 90 watts, but that can be available. So as you're doing your planning, a lot of this will come down to the endpoints that you have and kind of foresee in your environment and what their requirements are. So pay attention to that from a PoE perspective. We also then just need more power to be sourced from the switch as a whole. So before, a very standard full power PoE switch was 740 watts, maybe 800. And that gave you 48 ports of a full PoE capability. Now, PoE being 15 watts per port. Now, if you're pulling 90 watts from a port across all of these, you're going to run out of power in a hurry. And so we have secondary power supplies oftentimes that go into these switches, power stacking on some of these to bring a larger pool of power to the table because we're drawing so much power from these switches as before. So that's a change in the access layer switching side of things. And then lastly, kind of like with Wi-Fi 6 and this need for mgig, there's additional servers that more and more just have some kind of 10 gig copper capability. So 10 gig base T, you'll see, and base T, this mgig standard, they all support that 10 gig throughput to different servers that may be connected, out at the edge more, as opposed to within one of your data centers. So with all this adoption of increased throughput on our access layer, I do need to bring up the core layer a little bit because it has a cascading effect. And so there'll be a little bit of math thinking through here. But I want to just kind of give some background information on this. So for a long time, Cisco has had this standard of oversubscription ratios between the different layers within a campus. And so here is a traditional 3-tier campus design where you've got your core, distribution, and then access layer. And so we're talking a lot about the access layer today. But again, as the throughput increases down here, that's going to have a cascading effect of what we need to provide upstream. So many of you may have kind of a collapsed core, which just means the core and the distribution are the same thing. So just imagine one box here instead of these two. That's fine. Just kind of depends on your needs and the size of your network. But there is almost always some kind of connection between the access layer going up to this distribution or distribution/core. And from there, we're looking for an oversubscription ratio of 20:1. Now, what that means is the number of ports that I have down here in the access layer versus and the throughput that they provide versus the uplink throughput. For a long time, we've had the idea that running 10 gig and especially redundant 10 gig for high availability purposes, but also increased bandwidth, was plenty sufficient. And the reason for that was if you do 48 ports on one switch, and most switch stacks will support up to 8 switches, you do 2 10 gig uplinks, that gives you an oversubscription ratio of 19:1. So we're just underneath this threshold, but still within spec. The problem is, as we start to introduce mgig, and if you just did 8 of those ports, so obviously not all of these are going to be access points, most likely. If you just did 8 of those ports at that 2.5 gig spec, now I'm getting 60 gigs out of each switch. And again, for a switch stack of 8, or maybe it's a chassis with 8 blades in it, now I've got 480 gigs. Well, now those 2 10 gig uplinks are not quite sufficient. They drive me to an oversubscription ratio of 24:1. So I've exceeded that from a design perspective. And obviously, not everything's going to be running at the same time, and it's not so much about the full gigs, but the consistent communication. If you look at the buffers on these switches, they can get overloaded while they wait to send that traffic out. So it all kind of gels together after a little while. What I'd like to make the point on is it's really time to start thinking of 25 gig as they've listed here. There's also 40 gig and 100 gig options to go back between your access layer and your distribution layer. And I will not spend very much time on this chart because there's a ton here. This is, what I'll call a reference chart. So if you'd like this, just because there's a lot of good information here as far as what makes up different copper and fiber mediums, some of the different connector types that you can get, email me, email Steve/Ben, and we'll be happy to get this over to you. The point I wanted to make, though, is we have a lot of options on the optic side, and it continues to increase. You can see here 100 meg, 1 gig, 10 gig. We've been used to those for a number of years, but 25 gig, 40 gig, 50, 100, 200, 400. There's even, I believe, 800. Either it's been released or set to be released this year. So this backbone continues to increase. And what I'd like to focus on out of the access layer is this 25 gig and 40 gig space and the capabilities around there. So this is a list of the optics that you can get from a 40 gig perspective. It depends what kind of fiber you're traversing, be it multi-mode fiber, be it single mode fiber. It also depends on what distance you're traversing. So this is single mode fiber for 10 kilometers. This is single mode fiber for 40 kilometers. Now 40 gig, pushing a lot of throughput, has some additional expense to it. So the more you can fine tune what you actually need, you can save some cost here. So for example, here is a 2 kilometer single mode fiber optic. So if you've got some shorter runs, this could be a beneficial optic for you. But the one I'm most excited for is in this 25 gig space. Again, we've got optics for multi-mode fiber and we've got optics for single mode fiber, but you also see this new kind of designation. It says 10/25 gig. Now, for as long as I can remember, optics were single rate. And maybe somebody will correct me and tell me, no, there's been plenty of dual rate optics out there before. But in our access layer, back to distribution, they've largely been single rate. This is a 1 gig optic. This is a 10 gig optic. It doesn't change. But what will aid us in this transition from 10 to 25 gig is this dual rate optic that you see in front of you. And so the benefit here is looking back at our normal topology with our access layer and then distribution, is that oftentimes I see customers will upgrade the access layer, but they're not quite ready to upgrade the core or the distribution layer, or vice versa. They're ready to upgrade the core / distribution, but they're not quite ready to upgrade the access. So now with this dual rate optic, I can put a 10/25 gig down here, connect to the existing 10 gig, and then, a couple of years go by and we're ready to upgrade to 25 gig down the road, and we can do that. And now I only have to buy an optic once. I only need to install it once. I just need to change the configuration to switch it over to be the 25 gig speed. So that's a huge advantage as I look forward and figure out how we're going to transition from our current architecture and connectivity to the future architecture. So you can see they have this for both multi-mode fiber as well as single mode fiber. So those were some of the new technologies, and I did a little bit of product introduction here with the optics. But the good news is for all these technologies and requirements, and you've probably seen this slide before, Cisco has been working steadily on bringing a fully revamped set of switches that all work together. And I say switches, but also access points and also routers that go with that. So you can see here on the wireless side, we've got the 9100 series of access points. Now, I do apologize. All these are going to begin with 9s until we get to the routers, but that's just the way life is right now. So anything with a 9100 series designation is one of their access points. And they've got Wi-Fi 6E access points, Wi-Fi 6, outdoor access points, as well as some of these 5G kind of repeaters, if you will, that can help provide a backbone for cellular connectivity. On the access switch side, and many of you are probably familiar with this at this point, 92s, 93s, and 9400 switch models, 92 and 93 being this one rack unit style. And this slide needs to be updated slightly because the 9300X was just released that has 48 ports of 10 gig capability. But for a long time, we were at 48 ports of 5 gig, giving that M gig standard up to 5 gigs with 25 gig or 40 gig uplinks. And then obviously we have an option here for a chassis style that is the 9400. In the aggregate and core space, there is the 9500 and 9600 options. Again, single rack unit versus a chassis style. And then the 9800 are our wireless controllers. And we won't dig into routing today. In conjunction with all of these, and keeping in mind all of these, Cisco's been working hard on some software to increase security, increase analytics, and control and automation. Obviously, we'll dig into a couple of these later on in the coming webinar. But let's look at some new products from the Wi-Fi 6 and the 6E space. So 6 is a little bit older. And so again, you've probably seen a number of these products, but just to let you know what is available, these all operate the Wi-Fi 6 standard and have different capabilities. So the 9105 gets us started off, which is a 2x2 antenna, and also has this kind of hoteling option as well. So it's hard to see, but there are 4 ports connected with this 9105. A lot of times you'll put that in a single room, universities like this especially. We can combine the wireless and the wired simply in one unit. So that's a pretty handy option in many cases. The 9115, you can see here, ideal for small to medium-sized deployments. That gives us 4x4, so a little bit more robustness from a throughput perspective. And then we can jump up to the 9120, which is the same 4x4 antenna array. However, it includes Cisco's secret sauce, you will, their RF ASIC. And so I would categorize this one more as best effort and still does a very serviceable job from a Wi-Fi perspective, but doesn't measure the environment quite so well as the 9120 and the 9130, which has Cisco's RF ASIC in it, which helps manage all those communications. And so this one is designed for, as they say, mission critical deployments where wireless is a must, and has kind of become a good standard, the 9120. If you've come from like the 2802 series, this is kind of the evolution of that. And then I'll skip the 9124. 9130 is a more robust version of that, 8x8 antennas for high density deployments and some additional bells and whistles like full packet captures that help in troubleshooting. Then there's 9124, which is our outdoor rated access points that has external antennas. Kind of depends on what coverage you need. We can pair that with different sets of antennas. So for the past few years, this has been the product lineup. But this year, with the advent of Wi-Fi 6E, we have a new access point, the 9136, which has pretty much all the bells and whistles of the 9130, but in addition to that, has a 6 gigahertz radio support for that, I should say. Excuse me. And offers a lot. Now I'll move quickly here because Cisco is moving in a direction for many of you. I haven't really mentioned Meraki yet, but we will talk through their product portfolio. Cisco is moving to have a common platform, a common set of hardware that can run either Cisco's iOS XE or it can run Meraki's operating system. And so earlier this year, at Cisco Live was introduced this new set of 6E APs. Now you can still get the 36. This is dedicated to Cisco iOS XE and has some advantages, but there's a new set of common hardware that you will still want to order as either Meraki or Cisco iOS XE, but it can run either, which I imagine helps with manufacturing costs and standardization of software and that sort of thing. So we have 3 options here: the 9162, the 9164, and the 9166. Lines up much like the previous ones did as far as like the 9115 and the 9120 and 9130s. This one also, the 66 has you see an XOR 5 or 6. It's got a radio that can either be dedicated to the 5 gigahertz space if you still have a substantial number of clients that are running Wi-Fi 5, but then can also be converted to the 6 gigahertz space as well. So options there. Now, this is a fantastic AP. The one, headline distinguisher, I would say, between the 66 and the 36 is this one was actually built with dual 5 gig M-gig ports. So PoE redundancy is a big portion of that, of throughput wise, I think 5 gigs will be plenty for a while. So I don't know that we need 10 gigs across these. And really, they are deployed in active failover, so that wouldn't be available to you in any case. But from a high availability perspective, we have redundant links that can go to this. So if you have any kind of failure between switches, hopefully one of them is up and can provide the PoE to keep this guy online. So that is the 36. And let's move on to the Meraki options as well. So Meraki has a few entry level, we'll say, access point options that are Wi-Fi 6 capable, the MR28, the MR36, and then the 36H, which you can't see here, but has those 4 ports in it. That is optimized for hoteling or dorm room experiences. All of these are 2x2, so it'd be similar to that 9115 or 9105. I'm sorry, I said 9115, but that's 4x4, so I should take that back. Then there is the MR44 and 46 and 56. So 56 is our high performance, has an 8x8 antenna, and would be like the 9130 on the Cisco side. The 46 and 44 are both 4x4, with the exception of the 44 is kind of a good fit if you have control of your endpoint. So we've seen this be pretty popular in like K-12, where they are rolling out their endpoints and kind of forcing everybody to use 5 gigahertz as much as they can. So we got 4x4 experience there. And then there's a 2x2 radio for the 2.4 gigahertz space, which again has some cost savings if you just don't need that much 2.4 anymore. Then there are also some outdoor Wi-Fi 6 options, being the 76, the 78, and the 86. You can see both of these are 2x2, and then this one for higher density offers 4x4. Now, I did not go into the 6E models, but we actually did. Because remember, these CW 9162s, 9164s, and 9166 are dual purpose in that they can either function as a Meraki AP, connecting to the dashboard and being managed from there, or running iOS XE and connecting to a wireless controller and running those. So same specs, same capabilities, just depends on which flavor of management you prefer. Much like we had a 9136, we also have this MR57 as an option as well on the 6E side. So I mentioned wireless controllers. We also have a couple new options here as well. And this has been a change for Cisco in that now they leverage, or I should say the software is really deployable in a number of different circumstances. So it depends how many APs you actually need to support, how many clients you need to support, as far as which controller you'd like to go with. So that 9800 software, we'll say, iOS XE based, can be deployed just right on an access point. That's referred to as embedded wireless controller. So for small offices, even medium offices, right? We see up to 100 APs here. Everything can be run from this controller, and you can have it fall back to a secondary AP if you'd like for redundancy purposes. But that is the embedded wireless controller standard. You can also run this off of some of the, we'll say, medium level switches in the 9300s that have compute capabilities on them. And so you can run your 9800 controller as a software container on the 9300 switches. Again, looking at now 200 APs and up to 4,000 clients. There is a smaller form factor, 9800L, that can be dedicated controllers. There is a larger one, our medium one, the 9800-40. Now we're getting into some substantial environments, 2,000 APs, 40 gigs of throughput, 32,000 clients, and then the high end of the range, 9800-80, for those extra large environments. There's also, if you just want to run them as a VM on, VMware, Hyper-V, KVM, we can. You can also run them in the cloud. Now, usually for these, we're recommending some kind of Flex Connect deployment. There are some caveats as far as the throughput that you can get out of these is 2.5, and then increases to 5 depending on the NIC drivers you're able to support. So there's a couple caveats there, but if you're a distributed environment using Flex Connect, it's a pretty good option. All right. Now we can kind of turn our attention to switches that are supporting MGig and UPoE plus, and some of those changes that are happening in the access layer on the switching side. So again, end-to-end, Cisco has remade all of their switching platform to be in this 9000 series. So here is a chart, and again, I can send this over to you if you'd like after the fact. But just showing some existing switches, 2960X in particular, and kind of the natural upgrade that goes along with those. Here, the Catalyst 9200, the 3650, 3850, looking at the 9300, and now there's even a 9300X. The 4500 chassis into the 9400, and you can see that go along from here. We do a lot with the 9500 series from a distribution kind of core switch perspective, and even some 9600s for those robust environments. So all of this new hardware runs the same iOS XE software, and so helps standardize from a software development perspective a lot of the feature sets that we're looking into. On the same side, Meraki has pretty much the same flavor of switching. I've got a compact switch, a 100 series switch. I will call these out. I put them in line with the Catalyst 1000 series because they are non-stacking. So these can only be deployed in a single space. The 210, the 225, the 250, all are capable of being stacked. So those align very similarly with the 9200 switch. We've got a 300 series, be it 350, 355, or 390, that are similar to the 9300 switches. There is no chassis option for Meraki. Meraki likes to keep it simple, so they skipped that one. And then we've got some distribution and core switches from the Meraki lineup as well, all kind of coming together. All right, so I know we're near the end of this. Like I said, in a couple weeks, we'll have a bit more on the monitoring and management piece. But for today, let's recap. So new requirements, more video, more data, more things, especially in the IoT space and connecting in non-Wi-Fi protocols. And then just more power as more things are joined to the network, because the network provides a ton of function and capabilities and intelligence. We're going to need to power those things. And so there is a increase in the need for supplying power. Some of our technologies that support those things, Wi-Fi 6E, MGig, our 25/40 gig uplinks, and then all the different PoE specs all the way up to UPoE plus, giving 90 watts per port. And then Cisco's really standardized on all the 9000 series at this point, 9100 APs, 92, 93, 94, 95, 9600 switches, along with the 9800 wireless controllers. And similar for Meraki, we've got a consistent platform across the board. Now with the 9100 APs, because those are dual service, and then depending on your need, the 100, 200, 300, or 400 series switches. So